Hello and welcome. I'm Dom Hale for Australia's Mining Monthly and Mining Magazine. Today's interview is with Rob Bowell, geochemistry and geometallurgy consultant at SRK Consulting, provider of advice and solutions for the earth and water resource industries. Today, Rob is going to be talking about SRK's work around mine closure, and in particular, the valorization of mine waste. Rob, hi, it's great to have you here.
Nice to meet you, Dominic.
So, Rob, the narrative around mine waste has changed in recent years from risk and remediation to opportunity and circular value. From being seen as a liability to now a potential asset, how is SRK helping clients navigate that shift?
So, SRK has spent the last 50 years working in natural resources, advising their clients various aspects of mining. In the early days, it was very much focused around geotechnical expertise. Added to that, soon came water, mining, resource geology, and then environmental services. All of these are very important disciplines to be used within the assessment of a new mine and primary extraction of value from a mine site or an industrial site. Over time, mines eventually close, but very unusually, mines don't tend to close because they're completely exhausted. There's actually very few mines I know of where they were geologically exhausted. There's a copper mine in Namibia and Kimberley in South Africa where there is none of the actual host left for the ore. Elsewhere, it's economic factors which have driven closure, social factors, or political. Because of that, there is always some ore left behind, and there's some metal value which can be taken from the ground. And that's the first aspect of helping our clients to look at the value of a mature site, is looking at where primary value can first be extracted. Now, that can be ore which is in situ, or stockpiles which were forgotten, or looking at different technologies to exploit lower grade ore, which traditionally was uneconomic. But there is other value as well that mines carry. So historical processing routes may not have been as efficient as we can now carry out today. And therefore there is value left within tailings or a spent heap leach, or even within slag material, such that one particular mine I know of in Namibia, the Suma mine, it's reduced blast furnace slag, actually has the world's largest germanium and gallium ore body sitting within the mine waste. And we look at technology in which we can unlock this value and take these materials once cast as waste and look to extract it. And that can be for the primary resource that was originally extracted from that mine, or it could be in accessory elements or minerals which in modern society we now have a use for. So, for example, that could be minerals such as nepheline or magnesite, which are very good replacements for calcite as lower CO2 emitters in the production of cement or ceramics. It could be in the production of high-quality quartz or silica, which can supply industry with better fluxes and lower carbon emission fluxes for smelters of iron ore. It could be the primary recover of precious metals like gold or silver, which were inefficiently processed first time around, or the extraction of the so-called critical metals, such as the lanthanides, or as perhaps people commonly refer to them, the rare earths, or of lithium or cobalt, nickel, etc. Or of elements which were once considered a hazard or a pollutant, but now have a value. For example, cadmium in photoelectrolyte cells, or antimony for both defense purposes and electronics, or beryllium from pegmatite ores, which is a critical component of Kevlar, modern day body armor within the defense industry. So there's a range of values there within the geology of a closed mine site that we can look at. But there's further value still. Most mines have some interaction with the water cycle. As populations grow, many mine sites which were once rural no longer are. And in many societies now, it's considered unreasonable that either land or water resources should be sterilized by mining. And so there's opportunity that the mine site itself can be reused. I mentioned Kimberley a few moments ago in South Africa. Well, the underground mine workings at Kimberley might no longer produce diamonds, but they do produce mushrooms. And there's a whole industry set up underground where the environment is the perfect conditions for growing different types of mushrooms, and a business has been established to do so. And of course, the water which collects in the pit there is useful because it's a reasonable quality to irrigate those crops. In a similar fashion, mines that close in places like Arizona or northern Mexico are all in very arid environments where there's a big demand for water. And so cleaning that water and making it available for municipal or agricultural use has long-term value, not just for the miner, but also for society at large. And where mines perhaps can't be redeveloped that far, they have infrastructure which would allow perhaps solar farms or wind farms or even wave farms using fluctuations of water within a flooded pit in order to generate electricity. Or it could be they have a high geothermal gradient, and so a geothermal power can be extracted from the former mine site. That could be a possibility for many of the very deep mines in South Africa, for example. And so in all these ways, there is value still to be had from a mining venture, even if primary ore is no longer economic or is considered exhausted.
Well, thank you very much for that, Rob. In terms of your area of expertise, to what extent do geochemical considerations underpin decision making around mine waste reprocessing? Not just in terms of technical feasibility, but also environmental risk and long-term value creation.
Well, I'm going to sound very arrogant here by saying that geochemistry gets involved in every aspect of the mine life cycle, because when we look at components on a mine site, we're looking at chemicals. And every step within that life cycle, there's something that will need quantifying. And this is where geochemists can come into it. For example, in the original exploration and the evaluation of a mining or a potential mining area, geochemical exploration through looking at the anomalies generated in soil, water, sediments, or the rocks themselves is a critical component of evaluating and quantifying the resources in the ground. Exactly the same protocols and methods that we apply in that can also be transferred into the mining area when we're looking to optimize the use of materials, or in the environmental sector where we're looking to restrict the dispersion of those pollutants by mining activity, or of those chemical elements by the activity of the mine or of any secondary industries around it. And then in terms of the closure of the mine, then geochemistry comes into its own there again in quantifying the extent of land which needs management or control, and can also provide the requirement to understand the nature of engineering needed in order to make the land or the water or the air acceptable again, both to society and to nature at large. So in that sense, I would say geochemistry is a critical component which might not always be considered, but underlines all the other activities.
In your view, then, where would you say the most compelling value lies when it comes to reprocessing or repurposing mine waste? Is it in metals recovery, environmental outcomes, future carbon credits, or perhaps something else entirely?
I think it depends on each scenario we look at. Obviously, if you can extract precious metals or critical metals, there's an immediate value there. But where many mines now exist with large developing cities around them in many developing countries, the mines represent an organized piece of infrastructure which can be repurposed for tertiary industry, which will provide jobs and a financial safety net for that community. And so it might be completely unrelated to the primary resource exploitation that the mine was originally established for. If it's, as I said, if it's in a completely arid environment, It could be the water that the mine abstracts. The Konkola mine in Zambia, for example, is essentially the flow of water which feeds the Kafue River. When Konkola closes, it's hard to believe that that mine water will stop pumping, because the Kafue River will go from a very large, high-yielding rate, which brings as a lifeblood of much of central Zambia all the way down to the Zambezi, and the tap would be turned off. That would cause ecological, environmental, and social impacts throughout the length of that river, because of the amount of people that draw water from it. So it really depends on the scenario we're talking about as to where the most value comes from. And it could very well be it is those social or cultural requirements which override mineral exploitation on a mine site, because they have more value than the mineral exploitation. So one can't really say where does the most value come from as a universal statement. Valorization of old mines and mine waste has to be looked on a site-by-site basis, and not just by a geochemist, but it requires a fully integrated interdisciplinary team looking at all aspects, not just of mine planning, not just of infrastructure or resource development, but also connection with nature, connection with society around and in the vicinity of that mine, or any of its associated interactions. So, for example, if it generates a river like Konkola, it has a huge area of influence throughout Zambia. And there are other examples globally where this is also the case. And so for those areas, we're talking about not just regional studies, but national scale studies in order to decide what to do with the mine once it reaches its end of its primary mineral producing life.
Understood. So as regards the key technical or environmental criteria that SRK uses when advising its clients on whether mine waste valorization is worth pursuing, what are those points of reference?
Again, it really depends on the site and its infrastructure and its proximity to society, proximity to nature, the types of material on the mine site. Obviously, if the host rocks have elevated contaminants within them or within the mine waste, then a very important part of valorization is preventing degradation of any further land around the mine and improving the quality of the mine site. So one can't really say there's any one particular aspect that needs to be looked at first. And that's why it's very much an interdisciplinary study, which requires a number of professionals to work together to achieve a successful outcome.
Well, finally then, Rob, as to an indication of what the future of what mine waste management might look like, what innovative present-day examples would you point to?
I think a very good example for me is where Rio Tinto mined the Flambeau mine back in the 1990s. And because of considerations related to the surrounding high-quality dairy farming environment they were mining in, they only mined a portion of the mineral deposit. The rest they left in place so that they minimized the impact. And they spent the last 2 decades recovering the land, covering up that waste, returning it back to dairy farming, so that if you look at the site now of the Flambeau pit, you would be hard-pressed to see where a mine actually existed. And I think that reflects, for me, very much the fact that we have to consider mines as a financial revenue generator. And that's not necessarily just complete exploitation of all the mineable or mineral material, but also, again, the interaction with society and the interaction with the environment around the site. We can't change where mineral deposits occur. We can't pick them up and move them, so we have to mine them where we are. But the extent at which we mine, how we mine, and the level of restrictions we place on that are very much dependent by all these other interlinked parts of the life cycle of that area. And so I think more life cycle planning is going to be a critical part of it. And whilst perhaps not so innovative, I think The innovation will come by the site-by-site nature of how those life cycles developed. So they will be decoupled perhaps from corporate headquarters, and they will be devolved down to the mine site to be the primary generator of that life cycle for that operation or proposed operation.
Well, thank you very much, Rob. It's been enlightening. Today, I've been speaking with Rob Bowell, geochemistry and geometallurgy consultant at SRK Consulting. I'm Dom Hale. Thank you for watching.